Yes, sir.
A very good morning to all present here. Without mathematics, there is nothing you can do. Mathematics is the most beautiful and powerful creation of the human spirit. A very hearty welcome to each and everyone present here. I'm glad to welcome everyone to the one-day faculty development program on innovative applications of graph theory in computer science on the behalf of the Department of Mathematical Sciences. Now I request you all to rise up for the Tamil Thai Vazhuthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்பரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாளும் தக்க சிறு விரை முதலும் தரித்தனரும் திலகமுனே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழவை திறந்தியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Welcoming people is a part of our Indian culture. Sunshine is a welcome thing. It brings a lot of brightness. It gives me a great pleasure to welcome you all for the one-day FTP program. It's a great privilege for me to welcome our Honorable Chancellor, Dr. N. Veerayan sir, who is the pillar of CIMATS. It gives me an immense pleasure to welcome Dr. Deepak sir, Director, Academics of CIMATS. And I extend my sincere warm welcome to our beloved Madam, Dr. Ramya Deepak, Director, CIMATS. And I would like to take this opportunity to welcome our dynamic principal, Dr. V. Ramesh. On the behalf of the Department of Mathematical Science, I welcome our beloved chief guest. Dr. A. Joshi, working as a professor, Department of Information Technology in Dr. MGR Educational and Research Institute. Mom finished her bachelor degree in Holy Cross College, Trichy, and master's degree in Nirmala College for Women, Coimbatore, and pursued her MPhil in St. Joseph College, Trichy, and she also pursued her ME in Satyabama Institute, Chennai during her 2012. And Mom has completed her dual doctoral degree, one on mathematics from the Mother Teresa Women's University in the year 2010. And another pursued a doctoral degree in computer science and engineering from St. Peter's Institute of Higher Education and Research in the year of 2021. Mark has presented in papers in 8 international conferences and 4 national conferences and seminars, and also has published more than 30 research papers in national and international conferences. She has more than 25 years of teaching experience. In 2018, Ma'am has conducted 2 national workshops on gesture robots in collaboration with IEEE and CSI, and also conducted 10 days of India's largest skills certification scheme under NSDC and the guidance of the Ministry of Skill Development and Entrepreneurship. And Ma'am has organized a lab setup has been initiated for cyber and digital forensic lab. And she has organized many placement training programs and also conducted 7-day technical training programs in IoT and Python at Panimalur Institute of Technology. Adding feather to the cap, Ma'am has received Best Teacher Award in the academic year 2007 and 8 in Panimalur Engineering College, and also received Best HOD of the Year in 2018 and 19 CSI Mumbai. And she was also awarded Best Administrator and Best Academic Department 2017 by Dr. Kalam Educational Trust and Tribal. And in appreciation for the forecasting and ecosystem breeding government industry and academia by Texas Instruments. Not but not the least, without you all, this program would not be fulfilled. Now I would like to welcome our faculties from the different departments and my dear friends and research scholars. And now I would like to call upon Dr. Revati, Professor, Department of Mathematical Science, to honor her chief guest with a shawl. Thank you, ma'am. Now I would like to call upon Dr. S. Purnoy sir, Associate Professor, to honor our chief guest with the momentum. Thank you, sir. Now let me call upon our beloved chief guest, Dr. A. Joshi, to deliver her address.
Good morning to one and all present here. So I thank the management and Dr. Enian sir, Head Department of Mathematics, and Dr. Selvi ma'am and other colleagues in department. So I feel that very happy that I am in my own department, that's mathematics, because past 10-12 years I am in information technology. So today I am very happy that I am meeting my people. So it's basically, I feel very happy. So thank you for the opportunity, sir and ma'am. So shall I come down or? Okay. So here the topic given to me is innovative applications of graph theory in computer science as well as the computer science engineering we'll see. Before going into this, first I want to tell you, early days mathematicians only was teaching computer science. Basic, for when it started, all the colleges, mathematics department only have taught this, the programming paper and everything. Because maths people only can understand the concept of programming. So it was easy that day. Then when the goes, the people have come with the doctorate of computer science engineering and computer science, So now the department has split it. What happened? Our mathematics people have come far away from the application area. That is the true thing happening here. Nowadays, that's why they are not, computer science people are not asking help from the Department of Mathematics, because we are far away from them. The reason is we don't know what are the applications of mathematics, where it is applied, that gap has been happened. That's why we don't know in which area, in which field it is applied and how it is applied, we don't know. That's why they are not asking help from us. So they are having everything converted into algorithm by the mathematicians, and then algorithms are converted into programs. That's why they are using their program. Without knowing what is that basically happening or inside what is happening, they don't want. They are running, computer science people are running the algorithm. I am not saying they are wrong. We have given a very comfortable package to them. That's why. So when we want, if the computer science want to develop, mathematics also should have a hand with them. Then it will be, we can do wonders and miracles. So before going into this, so basically here we want to see where graphs are applied in computer science, what are the areas are they. Then I'll tell you some research scholars are here, as I told. So in what way we can club this mathematics and computer science so that you can easily publish the papers. So where it can be easily accepted. When it is application oriented, you can publish in your whether a mathematical journal or a computer science journal, it will be accepted. So we'll go first. Basic definition of a graph, mathematics definition. Then we will go how these graphs are defined in data structures. First I will go with the area where it is applied. So first it is a basic definition defined in our mathematics. Okay, graph we know it is a collection of vertices and edges. Edges is a link between the two vertices. So these vertices are called nodes in computer science and edges. Okay, so here they are applying this graph theory in a numerous field. So they are doing wonders. So one by one we will see. So this is a basic definition. I hope you all know. It is a graph, basic example graph I have taken. So this is a graph and the vertices, it involves with the loop and the parallel edges we know. So degree of a vertex means the number of edges incident on that vertex. And then one vertex, one edges incident on a vertex, then we can say both are adjacent. Edge and the vertex are adjacent. This is a basic graph. Graph means there is a mathematical way of representing the connection between any area. So that is collection of vertices and edges. So now here are the definitions and the types of graphs, everything used in data structures we are going directly. I will go to the field of data structures where it is used. Here, data structure, there are two types of data. Data structure means, so everything we want to store in a memory in the computer. So computer, all the informations are stored in the memory. So just like that we cannot store. So we need a procedure, we need a methodology. That is our data structure. How our data are stored. In a different structures it is stored. One is called a linear data, linear, another one is called a non-linear. Linear means this, we know that. Linear means degree 1 in mathematics, but your linear means it is easy way. So example of simple linear data structures are list. List means that list what we are having 1, 2, 3, 4. The name list what we are having, it is one type of a data structure. And then we have a linked list. Lists are linked with the memory where it is stored in the address. So every memory has an address. So where it is along with the address is memory, where it is stored, the address is linked, that is called linked list. And then circular links, there are so many. So apart from linear, we don't want to go in the same similar structure. We want to go to a different structure, that is called a non-linear. So best non-linear data structure is a graph. So in the special type of a graph is our tree. So both. So tree means you know very well what is a tree. Normal tree, it is from root to branch. And same way, there is no loop in that. There is no closed path in that, closed way. That is called a tree. Same way here also graph. Graph means you can have a closed graph. So previous slide we have seen it is a closed path. But if it there is no closed path, it is open, it is starting from the root to the branch, that is, it is said to be a tree. So here next we are having here, the graph is a non-linear, they are using to store information in memory using the graph structure. So the graph structure is called a non-linear data structure. So this graph, when it comes, we need to, when it is storing in the information in the memory, we want to retrieve it. We want to read it again. We want to use it again. Then we want to insert some information. We want to delete some information. All these are called operations. All these operations they have done in the graph. Okay, so this is a non-linear graph. So in this way, graph data structure are powerful tool represent, analyze and the relationship between the objects. Okay, so next one. So here it is useful, I want to tell you, this is a way how they are taking our definitions of graph in their way. So components of a graph, so here, so that I want to tell you here the field of a sports data science. See that the sports data science, now we know that we are all very, most of the people are very interested in football and cricket. Now we have a gambling also. Which team will be winning? Which team will be winning that gambling? That gambling, or we can say the prediction, which team will be performing in this way, that can be done with the graph. Here see the graph data structure. So here the team analysis will be understandable and the dynamic team performance also will be decided based on the graph data structure. Then the next one, it is the components. We know already vertices and edges. Then these are the graph they have taken, graph, trivial graph. That null graph means we have more vertices, but there is no edge. So then we have a trivial graph means only one vertex without edge. Then we have a directed, undirected graph. So some situation we want to fix the direction from one vertex to another vertex, only we can go. That type of case we will give an arrow mark. So that can be from A to B only possible. B to A is not possible. That is called a directed graph. So here the example, the diagram I want to show. So example. So next one, connected graph and disconnected graph. Connected graph means a whole graph. There is no subgraph, no subset, you know. The same subset here we are taking. So here the set is a collection of vertices and edges which are all connected. So here it is also subgraph. I can say that when you can divide into two subgraphs, then if you remove one edge, that is called a cut edge. So removal of one edge is dividing into two components. That component is called our disconnect. When you have more than one component, then it is said to be a disconnected graph. So connected graph and disconnected graph. So types I want to tell you because how this is taken. Regular graph means every vertex must have a same degree. Then it is said to be a regular graph. Then we have a complete graph. Here it is a complete graph. Every vertex can connect to every other vertex. So it's a very, very important graph applied in computer science. It is called mesh topology. So graph is turned into topology in computer science. So here data structure they are referring as a graph. When we are going to a network, the graphs are called topology. There it is a mesh topology because every node is connected to every other node. That is called a complete graph. So next you have a cycle graph and cyclic graph. Cycle graph means the graph itself have a cycle and then it's a cyclic graph means it is not the whole graph will not contain a cycle. It is a part of cycle is a part of a graph. That's it should be cyclic graph. So the directed, acyclic and bipartite graph we need. So here this we want to team analysis or a performance of a game. All these things we want to go in the team. So it is called a bipartite graph. So if there is no connection between, there will not be any common set between two sets. Common elements between two sets, two vertices. Okay, so this is the green and red. Then we can connect. So, I told you this is data structure is storing information in the memory. So, just like that we cannot store it. You know that memory is accept only zeros and ones, and then we want to store, the graph will be represented in terms of a matrix. Again they are using our matrix only, that is said to be adjacency matrix, or I told you list, adjacency list. Adjacent means When one vertex and edges are incident, edge and vertex are said to be adjacent. If it is adjacent, your matrix number will be 1. If it is not adjacent, it is 0. So zeros and ones are our adjacency matrix. Second representation is in terms of list. So matrix, adjacency matrix, we will go. So this is the way, two different way our graph is stored in the data memory. So here adjacency matrix I told you represented in the, if it is a weighted graph, then instead of here element is incident with an edge, then instead of 1, we will take that weight. So this is an example, adjacency matrix, and this is the next one is the adjacency matrix of a weighted graph. So there we had a 1 and 0, here we are having the respective weights. Then this is the linked list. This only I want to tell you, linked list, adjacency list. What do you mean by adjacent? When it is incident on that. Okay, here when you see B, vertex B, you have 4 different vertices are connected, A, B and C, 3. That's why you have a linked list for B, 3 you have. That means B is related, connected to A through an edge, B is connected to D and B is connected to C. That is the way we have to see. Next, this is the way. So I want to tell you, take your D. D also connected to A, B and E. See that D is connected to A is connected to B, B is connected. That means we should not see that A and B, whether there is an edge between A and B, yeah we have, but there is no edge between B and E. That is not the case. So E is adjacent to D. That is the way they are connecting it. B is adjacent to D. All the others are two vertices. E, for E, your adjacent vertices are D and C. That's why you have a D and C. So this is a box. What is the box? Second box. First box is saying which is adjacent. Next adjacent address will be there. That is a list. So this empty boxes will have an address of, first if you take a first one, address of D. Address of D, that is that, then computer will see that, then it will go to the address where D is stored. So this is the way graphs are stored in a memory. So our graphs are stored either in a matrix way or a list. Next we are going with, this I told you already, the operations. What are the operations we are doing? We will be doing the operation in graph later with class. We will see doing the operations as a tensor product because we are considering graph as a set collection of edges and vertices. So we will be doing a Cartesian product and tensor product. That is our mathematical way. Here they are doing, it is one single graph is used for to store all the information. So they want to insert the information, delete the information and search the information, or we want to read that values. That is called a traversal. Traversal means read the information from the beginning to end. All the nodes we want to read it. Reading is said to be traversal. Okay. So here 3 traversal we are having. That all the expressions are represented in terms of a graph and the tree expressions read. We want to read whether we want to read normally. That means in between operands we have an operator in middle. That is called in expression. Then we have a pre and post also. That we will see later. When you have to use a graph, wherever you want to give the relationship between entities, objects, we can use a graph. Wherever we want, whatever the problem, you can express that in terms of objects, and you want to express the relationship between the objects, then you can use a graph. The next one, here when you want to do the network analysis, network is a separate topic in computer science where it is all our system in our university also connected in a single network. So network we can go. Then we can go with the key players already we have given. So we can identify who will be the key player I think we all know when the cricket match, then the news, they will say that this time this player will be playing a very crucial role in the thing, the training is going on, all these things. So key player who will perform the well and improve the team performance. And the next one, whenever you want a prediction and recommendation, that also we can use the graph. So now we are going to the next real-time application. So data structures we cannot see in eyes, so we don't know. Now we are using every day-to-day life. We are using Facebook, Twitter, all these things. So Facebook is using a graph theory, using all our nodes. All the connections, what our account here is a node, and then the connection where we are all having friends is another node, we have a link. So they are doing analysis of this great network, Facebook, as well as the Google Map. Have you ever thought that Google Map is a graph? We are using Google Map. Without our Google we cannot live. Without the map. So all are based on map. I no need to explain. If the map is a graph, means you know very well every center places will be a nodes, and the street connected between this is a node, the edges. That's all. Google Map is fully graph. Without a graph, they cannot do anything. So Google Map, and then here see everything is using only our graph. So this is a graph they are using for a biology, and the world fully connected with our graph. And then we will see one by one to where we are applying in our day-to-day life our graph theory. So computer science, I told you, it is a data structure, and then in that, so what we want to know that in deleting, insertion and everything we want to know, but we want to see the shortest path. This shortest path only you are getting in your Google Map. Google Map says that this is the shortest route, that fastest route also. So fastest route is the edges which is having a very traffic, that also it is identified. Correct. So this is the way. So shortest path we want to find. For that only they have given algorithm. That only I told you all the algorithms are set. Say they don't want to know about the graph and the node vertices connected or not. If they applied it, they will get the answer. This way you go. How we are getting in a Google Map. So this is a Dijistra's algorithm and Prim's algorithm, Kruskal algorithm are fine to spanning tree. Spanning tree means we don't want to leave. For example, you take one from Google Map itself. We want to go from one place to other place. I want to go from Savita to India University, Savita University to. Then I want this vertices. I don't want to leave any route, any nodes, places I don't want to leave. But within this place, I want to find the shortest path so that I can reach my place. So that is called a spanning tree, means tree, subset tree, but it should contain all the vertices of the graph. Then it is said to be a spanning tree. So these two algorithms will give you what are the nodes should be there, all the nodes should be there in the connection. And with the minimum distance, that's why it said to be a minimum spanning tree. So these are the algorithms they are applying in the graph, and then they are getting a minimum spanning tree. And then, so you can read the graph in two ways, either horizontally or vertically. Horizontally, it is said to be breadth first. That means because they will be representing a vertex and the children. So computer science they will be saying in terms of children. So they can read from children left to right. That is called breadth first. Depth first means they will read in one direction, and then after completing one direction they will go. Depth is first. So next. So here there are three areas where we can graph is applied. First one is when it is a network, we want to analyze the structural property. Now in one area, or I can say that in Loyola College, Nungambakkam, the research is going on in graph theory, where they are using 10 years before we used only one-dimensional graph. Now they are going with the n-dimensional graph, but that is applied in chemical graph theory, but no application is applied. Just they are proving theorems. It is going on. So in the last 10 years, it's grown like anything, graph theory in Loyola College. But there is a gap that we have to see the application area. So they are very well versed in applying all the software also. That's the beauty there. They are using software, but they didn't take that our n-dimensional graph, which can be applied to all the area, but they did not take it. They are publishing paper and they are doing research in that area. Okay, we'll see to it. Next one is called a Veget-Clark network. It is, we can say that how the traffic, they are saying no. So this is a route, but there is a Google map, they are saying the route is slower because of a traffic. So this is the case, using graph only they are analyzing within a period, and this is called a transportation network. In that network, they will identify the traffic. So vehicular, how many vehicles are there, and to identifying that itself a separate section in the computer network is called vehicular network. So that's a research area some people have done with the research area. Very small work they have done. Okay, so they have calculated the probability of hitting a person when they are crossing the signal. That's all. That is a very one pattern they have applied. It very simple. For us, it is very simple. Calculating the probability, hitting the time will be given, and calculating a probability. So they got a pattern for that. So how we can apply it and easily we can get that only I want to tell you. So it's a vehicular network. Next you can find the dynamic properties, changing properties of a network using this graph. So then the next one, communication. So the communication network we did in computer science research, we did communication network, how the communication network can be developed and what are the basic structures we can use it for communication. That only we developed in computer science. Okay, next one, routing packet between, next. Next, second one is, it can be used in biology also. All our neurons are represented in terms of a graph. So biology, it is a very neural network, and the neurons are represented. Neurons are nodes, and which neuron is related, connected to another neuron. It is another graph theory application in biology also. Then we are having a next one, it is called different activities in the companies. When the companies you are having a different activities, that can be scheduling. Project scheduling is also another graph. So next you want to go computer science. Now I will go to the vertex coloring. Next. So here I want to tell you 3 examples where graph theory is applied. One is called our airline scheduling. Here, you all over one year, if I have an airline, I want to fly all over the world. Okay, but I want the crew. Crew is always, we know as a owner of an airline or a management of our airline or management of whatever it may be, we want to minimize the manpower or reduce our cost. So when we need to, this is a problem, using a graph they can solve. So I can find the minimum number of crew so that I can cover the whole world travel. So that problem is solved with the help of a graph. So the cities are our nodes, and the possible airline what we are having a route, that is our edges. With the help of that crews, we can select from different cities, so that we need a minimum number of crews, so that we can have a airline all over the world. So this is some example how they are representing into the cities and the airlines. Next one, map. Map I told you in between we are having a Google map is the best example of this. Next we have a Facebook and LinkedIn. Facebook, LinkedIn, all are it is using in terms of a vertex. And so I told you already, I am a vertex. Overall I am connected as a friend, or they will be connected by the edge. That's our Facebook, and LinkedIn also they are using that model only. Search engine. Search engine I want to tell you here. Search engine, our age, sir and myself and all know that when we early 10 years before, when we are searching a Google, what we are searching, that only we will get it. Nowadays, not like that. So here Google search is connected with the artificial intelligence. What is artificial intelligence? So that graph, from the graph itself. So suppose I'm searching for a graph theory. Already Selvi ma'am also searched for a graph theory. So she has gone with some other topics. Now when I'm typing graph theory, my Google search will be alert that the next question will be that. Next will be that. So that artificial intelligence, that intelligence will be taken from the past graph of our previous user. So this is a Google search has been improved. So all the Google search will be connected with the nodes. What are the information is that then how many times we are taking from, now we are one node and entity is another node. When I am searching it, there will be a connection. From that entity, what are the other connections are there? So system is ready to go for the next set of vertices what is asked. That's called a Google search. Here we graph, that one I told you all these things. So this is an example of a graph in a Facebook or a Google search engine. From this, they are categorizing the edges and the vertices, grouping the edges and vertices somewhat. First one. So what this is actually, they are grouping into a similar vertices and they are taking it up with the help of an algorithm. You cannot do it manually. So next here, these are the Google search. When we are having all these similar informations, we will be getting it off. So this is a way how it is our graphs are used. Next we are having called knowledge graph. This only I told you. Google search, they have applied artificial intelligence. What is that thinking? So system will think that what will be the next question. So this system will say that 10 years before when I am typing a Taj Mahal, it may be a Taj Mahal tea or maybe the symbol what we are having it on. Nowadays, this will with the previous search, it will understand that what the user is searching. Okay. So this is an example. See that all the dogs and animals are one side and plants are other side. All are same. It is an example of knowledge graph. So from this, now what you are getting? So animals are, this is a dog is an animal, cow is an animal. That type of a knowledge you will get. That's why it's said to be a knowledge graph. So this is a way it is collecting information. Suppose I want one information about any graph, or I want to know the application of a graph. So first layer and second layer, all the information will be collected and taken it. Okay, so this is a way it is collecting information. So the search discovery, we want to have an instantly, that's a graph, knowledge graph enables to search whether the people what they want really. So that will in future, that is the case. So here it is a first one, it is a Google have been developed this critical first step for building a next generation search. So the searching also will be very easier. So we all have a habit of if I want to know about the hotel nearby me, immediately what we will do it, we will go directly to the Google search and do it. Correct or not? That is done with the help of this graph, knowledge graph, to meet the next generation search. So knowledge graph only the Googles are saying. So Google is not only having their database, so it is augmented, it is attached all what is focused earlier, and that is called the training a set. So they will be having a set with the previous experience. So how old people are different from younger people, that experience only. By experience we are saying that this will be good and bad. Same way, when it has happened by the previous experience, they are training the data set and saying that this will be the future and all these things. So here tuned based on people's search. That only I explained earlier. Then the knowledge graph. So Google search I have given. So this only I explained it. So because the language is ambiguous, different meaning. So in what sense we are searching, that should be identified by the Google and then should give. So that also done by the graph. So these are the example. For example, we are searching for Marie Curie. Nearly 10 years before it will give only born and died and all these things. Now Google search will give the whole family history and her history and husband history and children history, everything we can get in the one page. So all these are best summary and everything, all these are possible with the help of clustering our vertices and edges. So knowledge graph. So these are the things, so many things because we are using. Now whatever Google you are searching, that is your knowledge graph. So now all informations are stored as a vertices and the connection between the two information is called this graph. So finally they are saying that enjoy the lifelong all these things. The best example, I don't know how many of you know that nowadays no need to write any speech or for whatever it is, write up we don't want. Yeah, youngsters are smiling because this is called Chat GPT. Just Chat GPT, we can go, just you can type, I want a welcome address. To welcome so and so, so and so. I want the word of thanks, so and so, so and so. Within a second you will get it. Within a second. So this is connected, this is a collection of related vertices who then giving the whole write-up you will get it. So you can use this chat GPT, no need of any English knowledge, you can read it. All are coming with a paper and reading nowadays. Excellent welcome address. Then we searched it, how it happened, then it happened with the chat GPT. So the one application where Google have developed it, then you can do it. Programming also, it's very soon going to come a programming also. When you are applying the concept, so we can use it. When we are giving a concept, then we can get the program. No need to study the languages, programming languages, we can get it. That's a ChatGPT. It's a product of Google. Next, biology also. So biology also, we can use biology. In biological network, I told you this is a combination of all the networks. So proteins are combined, metabolisms are combined, and gene regulation is a very big research area in biology. So based on the gene, you know all based on the Tamil movie. So that gene is a very, very important. What are the characters are in the gene so that the generation can be guessed. So this will be the generation 10 years back on these things. So gene, the regulation also you can use it off. So that can be developed into biological networks. So that into 4 networks, very special networks that are graphs, protein network, interaction networks, and metabolic and genetic. Whatever we have seen, they have separately splitted. So next we are going, after biological networks, next we are going with the neural networks. So we started with the data structure, now we are in neural networks. I think neural networks are familiar to you. So neural networks, I told you, we use a one-dimensional graph. So we want to go to the multi-dimensional. So the two-dimensional graph, we can say that in between we had a layer, input and middle layer, and then we had an output layer. So this is a way. So what the neural networks is a connection or significant discoveries okay. So here neural networks, why it has been developed, some of the problems cannot solve with the help of an algorithm. That time they developed with another network, it is called the neural network. Neural network, so here it is also very, very useful application in our society, that is called medical diagnosis. Very, very, very important. Nowadays medical diagnosis is a very good field, or we can say that we have to contribute as a research people and educators have to contribute this case, because nowadays so many diseases are coming. Correct, in between at a stage they are having immediately in the function itself the man died or a woman died. We are having so many diseases are developed that can be we can give the solution with the help of a medical diagnosis. So there are so many researches going on to develop
app or very easy to use it, so that whether we are healthy or not, we can check it off all the diseases. If you are taking a very small disease, that will be a very big project. You can get the government projects when you are connecting our graphs or other mathematical terms into medical diagnosis, so that we will get the government projects based on this. Next, we are having phase direction. We know we are using our attendance system also in terms of a fingerprint and a face. So phase direction, for that also neural networks is used, and voice recognition. So neural networks is the essence of deep learning. So now we are having a machine learning. Machine learning in the special case is a deep learning. So deep learning comes under our neural networks. So here all the neural network architecture is a human neurons. That's why we are saying that in medical field this neural networks is applied. So here it is, you can give a multiple input, then it will be executed in the middle layer, and then you will get the output, either a single output or a multiple output. So then you can predict. That only we want. Medical area, diagnosis area, we want to predict. No doctor is seeing now without a scan. Without a scan report, no one is seeing. Same way, so we have very simple example. I can say that Parkinson's. So we have the shake. The Parkinson's. So when we are having only the ECG or whatever that type of a test only we can get it. Instead of that, we can use an app. When they are drawing it with that, the values will be already trained. If it is this way, then we can say that the person is normal or have a disease. So that way this neural network is applied. So here we have the process is called the back propagation. That only neural network in that only. In the previous cases, what are the experience? That experience will be applied in the current case, so that it is there or not. That is called comes under image processing. Okay, so that neural network only. So there are different types of neural networks. I don't want to go this perception. Perceptron is a simple case. Only one layer will be having, and then that is a very important mathematical term. It is called activation function. So activation function is also our mathematical function, so that to give the prediction based on the previous values. The next type is called the feed-forward network. So previous the simple one. Now we have an intermediate layer. From the hidden layer, we are getting it. So output layer only will be applying the function. So here it is applied for classification, and then for speech recognition, face recognition, and pattern recognition. So the speech on the face pattern recognition also can be applied in the area called the cyber forensics also. So the next is called the multi-layer. The same thing, instead of one layer, we have a two layer. So two hidden layers then. So here it is supervised learning. That is the next one, machine learning. So I don't want to go in that machine learning. Next is a radial basis network. Here also, here the problem is layer. We have an input layer. The layer will be with a different special function we have, that is called a radial function. So instead of a radial function is a special function we are having it. So conventional neural network, it is a combination of backward direction as well as the forward direction. So conventional neural network only applied in our medicinal field. So this is layers we are having, conventional layer that will be pooled, taking together everything, and then it is a fully connected layer, then only you will have output layer. So last one is a recurrent neural networks. Here, see that self loop. So in this graph we are having a loop. That means the same information will be the input again, so that to give the output. So that is called a recurrent. Recurrent means we know that. So up to this we have taken a field where our computer science can be applied. So then we have applied all these graphs into a special network called telecommunication or communication network. So the graph we have given a very special structures, then we proved that these structures are better than the existing structures. So the structures are nothing but our graph. Topological structures are nothing but our graph. Our graphs are we applied our mathematical operations, tensor product and Cartesian product, and then we proved it different topologies. All the ring is a now network is called in the computer network subject. It is called a topology. So not our topology field. It is a topology is a structure. It is a logical representation of, there are two ways, one is a physical representation and the logical representation. To represent all these structure nature, we need a one number, that number is called topological index. So topological index is a single number representing the nature of the whole graph or a structure. So this is used in 1947. Wiener is a mathematician. He used and he defined this Wiener one number, saying the reflecting the property of a network or any other structure. So he applied in that only I told you in the chemical area, drug identification. So the property of our chemical bond or chemical component is represented by the graph. So carbon atoms are all represented as a nodes, and the connection between the, so we know that H2O and all these things. All these things are represented by a graph, and Wiener in 1947, he defined a number which representing the property of the particular component. So they used in the drug development. Then after 25 years, 1971, Hosaya have defined a number, he redefined the Wiener number. That Wiener number we applied in computer networks. So that's the next one, just to show the thing. So Wiener index, so it is called a Wiener, this only I want to tell you, so this I explained it. Particular topological index, so this after 25 years, Hosaya have defined again. So Wiener index is the basic for all the indices. Nowadays it is going on, the research is going on to find different components, one dimensional to now n dimensional. Result we are getting while the Wiener index or whatever it may be index related to it, all they are giving answer for n dimensional. N dimensional means regularly we can apply, whether it is a Facebook or a Twitter or it is our neural networks, whatever, wherever it may be, it can be applied this index, we can give the answer based on the nature of the network. We need a parameters, different parameters. That what we want that can be answered with the help of these indices. That's called the topological indices. So next part we will go. So there are network topologies are the ring topology. Okay. So that one I told you in for a network. Now we are coming into computer networks. So all the topics we have completed. Now here how we have applied our graphs into computer networks. I want to show how we have applied it. Okay, then how we proved it. This new structure what we used with the help of a graph operators is matching our networks, which is used in computer science. So here we have, there are two cases I told you. There is a network topology is concerned about logical topology. So there are two types of networks are called here a topology. So I want to tell you bus topology is there. Bus topology. Backbone will be there. The system will be connected. The ring topology is circle. So by cycle we have it. Cycle is our ring topology, and then we have a star topology. There will be a center node, then all others are pendant nodes. That's called a star topology. So these are the basic topologies we have. So with that we are developing, with the help of a bus topology and the ring topology, basically we developed many topologies and we proved that it are better than the existing one. So that so here it is a real time. Here also I want to tell you, Apple company is using a mesh topology, network topology explained earlier. Now I want to come to the real time. Some of the real time also, Apple company is adapting a mesh topology. I told you mesh topology earlier, it's a complete graph. Our complete graph is called a mesh topology here. So mesh topology, Apple company is using the mesh topology. Google is working with the mesh topology. And next, they don't want a centralized infrastructure. That means everyone is important for a Google. That's why they are not going with a centralized structure. Connected, everyone is connected. That's called the mesh topology. So here we have most small networks, star topology also. So I think I can go directly. So here we study the reliability. So I told you, based on the types of the networks, the parameter will change. So we are taking a computer network where packets can transfer from one node to another node. Informations are in the network. Informations are transferred through packets. So the packet transfer from one place to another place, there should not be any loss of packet. Then without less loss is called a reliability. Reliability means the message what I am sending, it is receiving as it is without any interruption, any loss of information. That is called a reliability. So when my network is not giving any loss, minimum loss, then my network will be a correct network, or I can say it is a strong network, which is that only we are having here. So we calculated reliability. Now reliability, when we are saying to computer science people, they are afraid of it because reliability can be calculated through probability. So we want to remove that fear also. Reliability can be calculated from probability of getting a packet without loss or minimum loss from one particular node to another node. So we don't want to go with that. We have what we have implied. You want one number, only one number instead of probability. We gave one number that says the reliability of a graph. That means when the packet travels a less distance, then automatically you can go. You can say that the loss will be minimum. So we cannot say that what will happen in between, but we can confirm that our packets are traveling at a minimum distance. So the total minimum distance the packet can travel in the graph, wherever it goes, wherever a node may be. But maximum distance, maximum hops, or what we can say the path, the length of the path, number of edges in the path, number of hops, maximum hops of one single number. Any packet goes around the network, we are giving a one single number, that number is called a Wiener index. So computer science also in 2000 they identified this Wiener index, which is applied in a chemical drug discovery. Now they applied in networks also. So we have taken that definition, same reliability is applied in networks, then it is published by Mao Gupta. Mao Gupta is the greatest computer science scientist, is working on Wiener index and the reliability of the graph or networks. So all these estimation we have, that is the thing. So instead of a probability, just I have explained everything. So source to terminal, everything. So the calculation of reliability, we have come into a single calculation, that total distance between shortest path between every pair of vertices we identified, and we added all the total number of paths and hops. I can say that single number. If that number is small, then my packet will travel with a less amount of time, so then the reliability will be more. Then, so that's the thing. So here these are the related works I want to tell you. Isaiah, I told you in 1971 he did. And the second generation topological indices, it is called the topological indices. So there is a first generation, third generation, and the third generation only they were they did with real numbers based on the molecular, because the base of everything is a molecular graph who Weiner have identified. So these are the papers where communication networks have applied it. So here first one, see the connectivity measures. So we have taken this point from this paper, so we can prove reliability with the help of a connectivity. So connectivity can be done with the help of a path between every pair of vertices. So that we have taken here. So there are, you can take remaining parameters also, max flow measures or commodity or this. So we have considered connectivity measures. So here also the first one, so the other author also have given that the measurability or reliability can be affected by these four parameters: connectivity, survivability, the damage resistance. So damage resistance you can understand from the word itself, and components working effectiveness. So from this we have taken connectivity. So they have introduced in the diagram, but we did not work on diagram. Diagram means directed graph. They are saying diagraph. So here we are going with the reliability. For a reliability, they all have working with that. But finally, they also come with the Weiner reliability analysis. So Weiner index and the index. Finally, they have come with the reliability Weiner index. So that's the thing. So I want to tell you on reliable communication. It's a related works only. So we adopted this methodology. So how, I want to tell you how graph theory is applied in computer networks. So I want to confirm the topic again and again whether I am going out of it or. So here, so what we did, we want to improve the structure of the network. First one, we want to give a new structures. For that, we applied graphs and the products. And different adding nodes or adding edges in a different way. That's the first one. So we are applying our mathematical way to improve the structure. Then we calculated the formula related to number of vertices. Number of vertices is a key point for the graph. So we constructed a formula for every structure we have defined. Then formula we calculated it. Finally, we used the Cisco package to prove that the packet transferred from one place to other place have taken a very less packet loss, and the efficiency also more. These are the method we applied it. So reliability, estimation of reliability, so we explained it. Here it is a formula of Weiner index. Weiner index of a graph, sum of distance between every pair of vertices. Okay, so next. So efficiency, we have used the Cisco simulators to do it. For that we use a ping command. So here this graph I want to so this is the main thing. So tensor product, I learned this tensor product from my mathematics guide Dr. Bhaskar Babuji, and then he only first applied this tensor product. That means product of two graphs. So he defined this, applied this tensor product, not defined, he applied it. So with the help of this, so we have constructed the new, we constructed with the help of a tensor product. P is nothing but our path graph. Path graph means a line, just line graph. Next one, C means circle graph. Circle we have. So here we have product, we got the tensor product of, so we got a new structure called 2,4 biregular graph. Regular graph means every vertices with the same degree. Here two different numbers will be there. So one is a 2, another one is a 4. That's why it's called the 2 regular. So we named all these things, and here the beauty is tensor product is applied to a simple graph, path and a circle. So we got a very beautiful thing. Whatever you apply it, you will get a regular graph, either a regular graph or biregular graph. So this degree will be same. So this is a line and the graph, then we constructed, this is a combination of edges we have defined it. So it's a new graph, combine A1, B1, A2, you can see that it is a product of product. Take one number, connect with all the elements of a B. Then take second element from A, connect all the vertices. This is the way. There are three 3 A1, A2, A3, that's why you are having 3 layers. Then 5 vertices in our cycle, so there are 5. So this is a combination because 3 by 5. 3 into 5, there are 15 vertices. That's all simple. Our product only. Just product of 2 sets. That we applied into a graph and then we got a graph. This graph, this one, because it is a 2 and 4. See that all this middle layer alone getting a 4, all the other are 2. So we have reconstructed this. We want to bring it to a very nice structure. This is very difficult when you imagine that it is a network with 1,000 vertices. It's very difficult to manage the network. That's why we have reconstructed it. So reconstructed, the previous graph only it is like this. So see that it is a vertex 4 and 2. It's a 2 by 4 graph. So previous, this graph is restructured. So then we named this as a tensor product, or it is butterfly graph, whatever it may be, or a cycle. It is we have considered to get the formula. It is a combination of cycle 4. So that way we have calculated it and we got the formula, a simple formula. It's for them to construct the algorithm very easy. All my graphs depends on number of vertices. So here, so by the MATLAB we have calculated all the applied number of vertices and we got it. Comparison between the old one for a cycle and for the tensor product. Then these are the parameters they accepted in computer science. They accepted it. So it is a data transfer and packet loss, data transfer from how many milliseconds it takes, and packet loss. These all we calculated with the help of a Cisco simulator, and then fault tolerance, and then how many number of hops. It is from 7. It is reduced to 6. And Wiener index is high, so that the reliability, Wiener index is reliability, so that if it is low, then it is high, reliability is high. So we have constructed this way many formulas. This is next tensor product of 2 rings. So first we are having, this is connected, this is a ring. So what I am now it is connecting is a ring. So we have constructed this way. First it is a ring, started from W11 to here also W11 to the whole thing. Then we have the other one. So parallelly we can see this is a new exact graph what we are having, a tensor product of 2 cycles. This is the graph we constructed so that easy to handle. Networks are easy to handle. That's why we have taken. Then this is a formula. Formula for because it is difficult when there is general n, so we have separately calculated a single formula for n is even and odd. So this is a vertex set algorithm we want to give because it's a computer science, we want to give the algorithm, and then so we applied in MATLAB and we got the answer, and Cisco packet transfer hybrid topologies. This is a way. So this way we have applied. This is one is called a tensor product. Similarly, this is a very easy Cartesian product of line and a circle. Cartesian product of line and a circle. So it's a beautiful how we got we have got it exactly. It is also a clumsy structure. We have converted that into this format. Here, what is this? If it is P4, there will be 4 circles and 7 lines. So it is easy for us to say that PMCN. So there will be n circles and this way. So it has come with a difficult. So it's like a web. So that's why we have named it as a web structure, structured web topology. It's a new topology we introduced with the help of the graph theory. So graph operators. It's a new topology. Then the formula, and we calculated the formula. Then we implemented as usual. So the same way we have applied, then we introduce instead of operation to operation, then we introduce in terms of new edges. So regular topology means a cycle itself a regular topology because the degree between 2. Then we introduce an edge and we have a node and we introduce a new edges. We tried with the different topologies. Every topology we have taken as a new one is not in an existing computer. So this and all, same thing we did. Next here, we want to go for a complete graph. Mesh topology. Mesh topology only applied everywhere. Google taking a mesh topology. Apple is taking a mesh topology. So from the path, how we can move to mesh? So from if you have a one path, that can be converted into a complete graph. If you have a single graph line, that can be complete into how we can complete it. So we had a method procedure. If it is a vertex, the distance is 2, you can connect by an edge 1. So we have connected like that. A one line we have taken in that way. 2, when there are 2 edges, we connected by a single edge. So that the distance 2 is reduced by 1. Finally, we reached with the same thing. Cycle also we have done. So first stage, second stage. Then finally, every number of terms what we are having for one certain state, we are reaching our mesh topology. Mesh topology, why we are trying it? All the companies are need a mesh topology. If they have only a network is having only like a bus network, they can apply this procedure. They can bring into a mesh network. So the formula and all we have given. So this is a diagram. We got it from MATLAB. Then we applied it. In the side from cycle we have taken. Then I want to tell you trees. Tree is special. I want to tell you the tree. This is a tree. So here only the spanning tree and all we were talking about spanning tree. Here it is a ready-made spanning tree. Okay. So here it is derived from the molecular graph. So nowadays they are using the molecular graph in a different layers, saying that n dimension. So that n dimensional we have been very difficult to handle now. I calculated different vertices indices for n dimensional layer, very difficult. It's very difficult to do that. We have constructed that n dimensional converted into a tree. So this tree is nothing but the hexagonal shape of our chemistry component, that every point represents the hexagonal component. So the center point of hexagonal component we have taken it. Now for that we had a two type. It is called odd. We have a even also. So even we had it. So this is a even. Okay, same way we have a T4, T6 and T6 we have. See the difference, T6 and T4 will be there. Okay, so here in the first one you have a Y shape. Here you have a, this is called even. T6 is even. You can identify the difference from the first one. So this is a node where we can, all the cellular companies can use this tree, where we can extend this tree. It's a binary tree. Binary tree means you can go with only 2 children. Binary tree can extend at any number of vertices, no problem. Our formula will give the answer for you, reliability. You will get the answer for the reliability. So this is a formula you can apply in the MATLAB and you can get the answer for your network. Whatever any number of vertices what you want, you can do. So next the circle we want to span. That is called star topology. With the help of a star topology and ring topology, we define some other topologies. So this is a different star topologies we defined. Next. So this is a graph defined by definition is given by my mathematics guide, Dr. Bhaskar Babuji. So this is a graph he derived from mesh or complete graph. Complete graph, he removed a number of vertices n into n minus 1 by 2 I think so. Number of vertices he removed, then it depends on the number of vertices. We got a planar graph. Planar graph means you can draw the graph without intersection of edges. Planar graph is also a very useful application in computer science. So planar graph separately, planar topology we have studied, because the network without any intersection of edges is easy to handle. The next one is mesh topology problem is everyone will be a master, because everyone is connected to everyone. Certain problem every master is doing a problem. So they don't want to have a single master also. So we gave the solution. This is a network derived from mesh network, so that there are 2 masters are communicating to all the nodes. So if one master is having a problem, another master will complete the work. So these two are, your V1 and V2 are masters connecting all the nodes, having a communication with all the nodes. So that communication will not be stopped even one person is not there. Okay, that is the case. Here what we did a reverse work. We did a reverse work. What we want, if you give a number, that number as a reliability, you can construct a graph. If you are saying 1000, so I will construct the graph whose reliability is 1000. It's a reverse problem, inverse problem. So for we constructed a graph, we got the reliability. Now if you give a number as a reliability, I can construct the graph which is having number as a reliability, but the structure will be same. So the structure is same. You don't need to confuse with how to construct the structure. No need to. So what this beauty we identified, except the number 2 and 5, all the numbers have come as a reliability for this network. So we did. So here, see, from the complete graph Kn, we removed the number of edges n1 and n into n minus 1 by 2. That we have removed one by one, so that we have shown it. See, this table says it is a reliability number of all of the graph what we have shown planar graph. See, all the numbers will be there. From 1, 2 will not be there, 5. Except 2 and 5, we got all these numbers or reliability of a graph. So you give any number, it goes, you can apply it, so somewhere it is matching with some other numbers, but you can go, this table can be extended to any number, lakh, 10 lakhs, whatever it may be, you will get a graph. So it gives a number of vertices. When the 1000 is a reliability number, now we need a number of vertices. If we have a number of vertices, this is our structure, we can write it. That's all. So we have given a formula to find, so except that is all this explanation I gave you, then 2 and 5. Then this is a formula. N is a reliability number I want. Okay, this will be given, 1000 has been given. With the help of 1000, floor function is applied to n, we can get the number of vertices n, that's all. Then we can apply it. So from the Kn you can remove it, or you can directly go to the structure, that's all. So this is the final thing we have given you. You can construct a graph with a specified reliability. It's an inverse problem also we solved it. We gave the particular graph where all the numbers except 2 and 5 will be a reliable number for that particular graph. So with this I will complete my lecture. I hope you all enjoyed and it is informative. Thank you for patient listening.
Thank you, Mom. It was a great speech. From your words, we came to know how LinkedIn, Google Maps and neural networks have graphs as their basis. So, Mom, now, as you said, like many theorems were developed on n-dimensional graphs, but we are sure that like soon we will work on the application part. Thank you, Mom. So now I would like to call upon Dr. Sita Lakshmi, Associate Professor, Department of Mathematical Science, to render the vote of thanks.
Good morning to all present here. On behalf of Department of Mathematical Science, I would like to thank our Chief Guest, Dr. Joshi ma'am. In spite of a busy schedule, she accepted our invitation and she came here and presented a valuable speech. Thank you, ma'am. And I thank our Chancellor, sir, Dr. N.M. Veerayan, sir, for his inspirational words and academic works and support given to us. And I would like to thank our Director Academic, Dr. Deepak, sir, for its continuous motivation given to us. And I would like to thank our Director, ma'am. Without her support, we can't do anything here. So I would like to thank him again, Director, ma'am. And I would like to thank all the research scholars and faculty members who are present here. And I would like to thank our department faculty members and research scholars Without their effort, it is not possible. So I like to thank everyone present here. Thank you.
Thank you, ma'am. Everybody please rise up for the national anthem.